friends, a very good morning to one and all. Today we will discuss on convergent sequence. First of all, we will know what is a convergent sequence. A sequence an is said to be convergent if limit of the sequence exists. Limit n tends to infinity an exists, then the sequence is convergent. Now we will learn some important results on convergent sequence. If any sequence an contains more than one limit points, then this sequence is not convergent. Every convergent sequence is bounded, but converse is not true. Now we will learn with the help of some examples. If sequence of 1 by n limit is 0, then it is convergent and also it is bounded. If sequence of -1 power n is equal to -1 1, therefore it is not convergent, and sequence of -1 power n is bounded, but it is not a convergent sequence. Similarly, sequence 1 plus -1 power n is bounded, but it is not convergent sequence. Now we will take another example. An is equal to 2 if the number is prime, and the number itself if the number is not prime. Then its sequence will be sequence 1, 2, 2, 4, 2, 6, 2 and so on. This limit point is unique, then also it is not convergent because it is an unbounded sequence. Now we will discuss some other results on convergent sequence. Unbounded sequence is never convergent. A bounded sequence at unit limit point implies convergent sequence. Every convergent sequence has a limit, or a sequence cannot converge to more than one limit point. Limit of the sequence an plus 2 is equal to an plus 1 upon 2 is a1 plus 2a plus 2a2 upon 3. Limit of the sequence an plus 2 is under root an plus 1 is equal to cube root of a1 dot a2 square. Now we will learn about algebra of limits. If limit n tends to infinity an is equal to L and limit n tends to infinity bn is equal to m, then limit n tends to infinity an plus or minus bn is L plus minus m. Limit n tends to infinity an bn is equal to ml. Limit n tends to infinity an upon bn is equal to L upon m, provided bn is not equal to 0. Limit n tends to infinity an is equal to L is not equal to 0. Limit n tends to infinity cn is equal to c. Limit n tends to infinity an is equal to cl. Discuss a question. Let an is equal to bn plus 1 upon bn, where b1 is equal to 1, b2 is equal to 1 and bn plus 2 is equal to bn plus bn plus 1 for all n belongs to natural numbers. Then limit n tends to infinity an is, we are given with 4 options. 1 minus under root 5 upon 2, option 2 is 1 minus under root 3 upon 2, option 3 is 1 plus under root 3 upon 2 and option 4 is 1 plus under root 5 upon 2. It is given that b1 is equal to 1, b2 is equal to 1 and also it is given that bn plus 2 is equal to bn plus b n plus 1. Therefore b3 will be b1 plus b2. We take n is equal to 1 here. So b3 will be b1 plus b2, which is equal to 1 plus 1, which is 2. b3 is 2. Similarly, b4 is b2 plus b3, which is 1 plus 2 is equal to 3. Similarly, b5 is b3 plus b4, which will be equal to 3 plus 4 is equal to 7. B increases as n increases. b1 is equal to 1, b2 is equal to 1, b3 is equal to 2, b4 is equal to 3, B5 is equal to 7. B increases as n increases. It is given that an is equal to bn plus 1 upon bn. It is equal to next term divided by previous term. N tends to infinity, an is equal to limit n tends to infinity an plus 1. And it can be written as limit n tends to infinity an plus 1 can be written as limit n tends to infinity bn plus 2 upon bn plus 1. And it can be written as 1 plus bn upon bn plus 1. Consider limit n tends to infinity an is equal to L. On considering limit n tends to infinity an is equal to L, we get L is equal to 1 plus 1 by L. L square is equal to L plus 1. L minus 1 is equal to 0. On solving it, we will get L is equal to 1 plus minus under root 5 upon 2. And the value of L is equal to 1 plus under root 5 upon 2. We will take only positive value, not negative value. Now we will discuss a question. The question is, if sequence of an is a convergent sequence, then limit n tends to infinity and an plus 1 minus an is. Limit n tends to infinity an is equal to L. An is equal to limit an plus 1. Here we considered limit n tends to infinity an is equal to L. Therefore, limit n tends to infinity an plus 1 minus an will be n L minus L which will be equal to 0. Therefore, the correct option is D, which is 0. Thank you and have a nice day.